Okay, so I thought I'd give an example, hi by the way, of how MillenniumOS allows you to run jobs on the Milo with the minimum amount of manual work. So the idea is that our post processor for Fusion can create gcode that looks vaguely like this, which is sort of supposed to be a little bit more similar to how a 3D printer would output G-code, where you send the G-code file to the printer and the printer just does everything it needs to. Obviously that can't work with a mill because there's different setup requirements, but this is supposed to help with some of that stuff. So you can see here we send tool details, then we do some basic setup like setting the movement configuration, homing and parking. Then this is where it gets important. We can probe a work offset. So here we'd want to probe work offset 3, and then we switch into it. And then here we change to one of the tools that we've configured at the top. Then we start the spindle. You'll notice here that we're using a custom G-code 3.1. So that essentially starts the spindle and then waits for it to get up to speed. Now how it waits can be configured. So if we have spindle feedback, then that would allow us to wait for the spindle to be up to speed from the feedback input, or we can just wait a set period of time. We then have some example like cutting moves here, and then similarly, I think I just deleted some of it. Yeah, there we go. Switch to a different tool, start the spindle again, more fake cutting moves, switch to a different work offset, which might indicate that you were changing the rotation of the stock for a separate operation. So that switches into a different work offset and probes a different work offset, changes tool, and then ends the program. So we're going to run through this and see how far we get before I make a mistake. So let's start by actually running the file, and you'll see that the machine will home itself. Like that. So the machine's now homed, and you can see on the screen that we have a pop-up box that says that probing will set the origin of WCS3. So essentially we're going through the setup for this job completely automatically based on what's in the G-code file, but asking for user interaction. So it tells us here that we're going to be setting the WCS0 on G56. So we go OK. It then says, please install the touch probe. Now it knows that my touch probe isn't installed because it's not switched to the touch probe tool in RepRap firmware. So it only allows you to use the touch probe when the tool is selected, and it will only select the tool when it's actually detected that the touch probe is installed. So I'm going to install it in the spindle and plug it in, and I'm going to tighten it up slightly just because I'm testing. Doesn't need to be particularly tight. Will do. So you can see my touch probe connected. This box actually asks you to manually activate the touch probe when you click OK, and that's so that we know that it's connected. Most touch probes are, well, the cheap AliExpress touch probes are normally open, which means we can't detect cable breaks. So it's really important that we check that the touch probe is working before we actually try and do anything with it. Otherwise, we might crash the touch probe if it's not plugged in correctly. So I hit OK, and you see this notification down the bottom that says we're waiting for touch probe activation. So I can activate the touch probe, and that shows that it's active. So I hit OK. Now it's going to probe the reference surface because I haven't probed it yet since I've started the machine. Now it already knows where the reference surface is based on the configuration wizard that I ran, and it's now going to probe the reference surface. So the reference surface is used with a static distance to the tool setter activation point, which was probed during the configuration wizard using the initial datum tool, which for me was just a dowel, and that allows us to work out the length of the touch probe versus the activation point when we probe a normal tool. So once we've probed the reference surface, which is what's happened there, it goes back to 0, and then it proceeds in the job. So it's basically asking us to probe the workpiece now. So I mean, I've got some tape in here. You can see this here. I know the details for this tape, so I'm going to do a circular bore, it tells us that so this is particularly for the probe bore probing cycle. This now explains the probing cycle and how it's going to work. So it says we're finding the x and y coordinates of the center of a circular bore, and we're going to move downwards into the bore and probe outwards in 3 directions. So it then explains what questions we're going to be asked. So we're going to be asked for a bore diameter and an over travel distance, and it explains why we need those. It then says we're going to jog over the vague center of the bore, and it gives us a warning because jogging in RepRap firmware doesn't watch the probe status. So if you jog in the wrong direction, you can crash the probe, obviously. We then get asked for a probe depth. We know all of these things. Okay. So 75 is the approximate bore diameter, and I'm going to say 10 because I want to be pretty inaccurate with this, and then I'm going to jog vaguely over the center of the bore based on, it's going to be a bit out, but hopefully I'm close enough with the details that I've given, and I'm going to go down, and that should mean that if I enter 10 here, so that's a positive value, and that means how far down we're going to go into the bore. So when I hit OK, it then explains that the probe is going to move 10 millimeters into the bore and probe outwards towards the edge in 3 directions. So that's what's going to happen here. So we move into the bore, and now the probe cycle's happening. We're moving outwards towards the edge of the bore. Now, how many times it repeats here is based on the configuration of the probe itself in RepRap firmware. So this particular probe is configured to do up to 10 retries with different feeds and speeds for fast and slow speeds. So that's what it's going to do. It's up to 10 retries because it's also configured with a tolerance of 0.01. So as soon as the probe hits 0.01 variance between successive probes, and well, not successive probes, between the average of the probed points and the next probe, it will then abort the probe cycle early. So it doesn't generally have to run 10 probes to reach the accuracy that we're looking for. So you can see here, hopefully it gets to that edge. Yep. So that's probed the 3 points of the bore, and once it's finished doing that, it's going to move into the center of the bore and then just above the surface. Now it does that so that we can move horizontally without running the probe into anything in subsequent moves. So that is the center of the bore. Now it tells us that the probe cycle is complete, but we haven't zeroed the Z in WCS3 yet. It knows that because it can look at the offset of the work coordinate system, and it knows that if it's 0, it's probably not zeroed out yet. So it asks us if we want to run another probe cycle. So we go yes, and it starts again with the probe workpiece macro, but it allows us to select a different macro here. It tells us that the origin is already partly set, and it shows us X is 171, Y is 74, and Z is 0. So we know that we need to probe Z now because it's still set to 0. So we go single surface. This explains a single surface macro. So it says it's for probing on a single axis, and what it's usually used for is to find the height of a workpiece. So we go OK. It says it will only return accurate results if the surface you're probing is perpendicular to the axis you're probing in. So say, for example, your workpiece isn't square against X, then this macro wouldn't find an accurate position of the surface to zero the machine on, because you can't make that assumption. So it then tells us we're going to be asked for an axis and a direction, so we go OK. Then gives us the jog warning again. And then we get asked for a probe depth. That's only if we're probing in X and Y, because obviously we have to drop the probe down to probe the surface on those axes. So then Z negative is highlighted by default because that's most situations where you would be using this macro. So we press Z negative, and then I know I want to move 5 up, I want to move 50 back, and I want to move 10 forward, and that should put us over the edge of the tape. And then I hit OK. It says we'll now probe down towards Z negative, so this should set our Z offset of the work coordinate system. So we probe down, and then we probe down again, and once more, and the final one. And then now it knows that we've got the touch probe activated, and it knows we don't need the touch probe anymore because we've just tried to switch to a different tool, a cutting tool. So it asks us to stow the touch probe for safety purposes. So I'm going to stow my touch probe cable, and I'm going to remove the touch probe itself, trying not to hit the GoPro. And I have stowed the touch probe, and I click OK. Now it says a tool change is required. You'll be asked to insert the correct tool and the tool length will be probed. So again, explaining the process so that the operator knows what's going to happen next. So I go OK. It then asks me to insert the flat end mill. I'm not going to insert a flat end mill because I don't want to. I've got a dowel. I'm just going to use that instead. So insert the dowel, time it up slightly. That'll do. And it says continue when ready, cancel aborts the running job. So if you say, for example, you wanted to work on a different part of the job, or you just are not happy with the way the job's running, you can always cancel it when the tool change comes up. And obviously with RepRap firmware, you can pause it or cancel it almost any time. So I'm going to hit continue. It's then going to probe the length of the tool using the tool setter. I don't know if you can actually see that on the, oh, you can see it on the GoPro, good. So it's going to, using the same probing macro, it's going to test the length of the tool again, and this is essentially calculating the offset of the tool versus the installed length of the touch probe that we don't know, so we have to calculate it. So this is using the same underlying probing macro as the touch probe to work out the length of the tool. So now it has the length of the tool, and it zeroes the machine, and it then moves back to the parking location, which is over the center of the bed. And now it tells me tool change complete, continues to start the next operation, or pause if you need to do manual further tasks. I'm going to hit continue. Now this is something that only happens if you have expert mode off, and it says it basically occurs whenever you try to start the spindle. It gives you a warning and says we're about to start the spindle, be careful, make sure you close the door, wear your eye protection, all that sort of stuff. And it gives a cancel, which again aborts the job. So I'll hit OK. Now my spindle isn't going to spin up because it's not connected to the board, but we wait 7 seconds for it to accelerate, and then we start the job. So this is going to do some cutting moves or example cutting moves, and then it will finish and ask for a tool change. So that's it, it's moving to the top of the travel again and finished. And now it's asking for a tool change. Same warnings as we did last time. So instead of inserting a different tool, all I'm going to do is change the length of this one slightly, so that we can confirm that the tool ends up at the same place. So the spindle should now move further down into the tape before, while it's machining, as the tool itself is shorter. So I go continue, moves back over the touch probe, the tool setter, and then probes it. Obviously I'm running, you don't want to run into the tool setter too fast, so we just have to wait for this to happen. There we go. Touched. Now, one of the modifications that I think would work really well for this is to probe tools that have a wider diameter than the tool setter tip itself. So for the first probe, we probe the middle of the tool, and then we use the radius of the tool. I'm just going to continue this job. We use the radius of the tool that we have to find a position, 3 positions on the outer radius of the tool, and then we probe those to work out if they're lower than the center of the tool. So that means we could probe face mills to find the actual Z offset of the face mill, rather than having to offset them with the touch probe manually. So you can see there, it's then asked to set the origin of WCS forward to the probe location. Now, what should have happened there is the tool should have retreated back to Z0 before that happened, but it hasn't. So that's something that I'm going to have to fix. So I'm going to go OK. It now returns to Z0 because the tool change has a sorry, not the tool change. Yes, the tool change for the touch probe has a parking mode in it. So what that means is that we need a parking call above the at the probe workpiece macro, in the probe workpiece macro. So that's a very simple call because we've already got the macro written for that. So it's just one command to enter into the probing macro. So now it's asked me to install the touch probe again, and the reason for this is because I've changed into a I'm going to change into a work coordinate system that doesn't have an offset configured. And the reason for that is because that offset might be something that happens during a job. Like it might indicate that you're rotating the workpiece because you've machined one side of it. One of the other options for this is that we could output the probe workpiece command multiple times for different fixtures, and that could be used for when you're machining multiple parts at once, and you could switch into different workspaces during the I've almost forgot to activate the touch probe there. That could be used to switch into different work coordinate systems for multiple pieces that you're machining on the same time, at the same time. So what you would do is you probe each of the locations for the multiple pieces at the start of the job, and then during the job you would switch into those different work coordinate systems to machine those multiple parts. Now, the way I'm using this at the moment, and the way the example code is currently set up, the example gcode, is that we're machining one item, and we're using the work coordinate system switches to indicate a rotation of the workpiece. So again, this is now probing G57, so it's asking to do the probing cycle again. Now, this can be a bit long, obviously, if you're being walked through every single step. So it can be a bit of a pain, but it's better to do this in this manner than having people that are unsure about how the system is going to work. Now, the idea with the expert mode is that it will turn off a lot of the explanation steps that are happening during this process. So it will be faster to run through these steps when you turn on expert mode. Now, I'm not 100% sure if it should just be standard mode and expert mode, or whether there should be some sort of intermediate mode as well, but it should be easy enough to switch between the three sort of methods of ways of doing things. So right now the machine is going to set the work coordinate 0 of G57. It's essentially just running through the bore probe again, because the bore probe is the one that I've tested the most. And once it's done that, and we've set the 0, it'll then ask us to do a tool change again, so we'll do the tool change. This is just a pretty good test to see that running this stuff multiple times actually works in practice. It's going to make for a relatively long video, but better to actually see what's going on. So there's a bunch of other things that come along with MillenniumOS. So say, for example, variable spindle speed control, that is currently enabled. That's controlled by the by the post processor as well, so it can be enabled or disabled in the post processor or in the machine. So we want to run another probe cycle. Again, it's giving us this information. Where are we? Single surface. Okay. 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 Z minus. Up 5. Back 50. Forward 10. Probe. Now probe downwards. There we go. And again. And once that's done, we will have the work coordinate system 4, G57, zeroed as well. And it should be pretty close to what work coordinate system 3 is. So again, it's asking us to stow the touch probe. So I will do that. Again, trying not to hit GoPro. And what I will do is put the dowel back in, but this time I'm going to leave it stuck out quite a bit, just as an indication of a longer tool. Make sure my cable's folded back. And again, tool change is required. I changed a little bit early, but this is all part of the single tool change procedure that tells you when the touch probe needs to be removed as well. So insert tool 2, continue, probing it again. Now this tool was already used in the previous work, but we've had to remove it and put it back in, which means we need to reprobe it, because there's no guarantee when you remove and put a tool back in that it's going to have the same offset. So essentially, every time we switch back to a tool, even if it's been probed before, we do a reprobe of the tool offset, and we start from that point. So there we go, probing finished. A longer tool then asks us if we want to continue again, so we go yes. Check the work. Yep, waiting 7 seconds for it to accelerate. And let's see what happens. Not quite. Need to work on that. This is probably a fault in my gcode in the actual file rather than a fault with the macros, but I'm going to have to check that. Anyway, that wasn't too bad. We got to the end of the gcode file. It got processed. So there's just that final movement down again with the longer tool that I think I probably messed up in the example gcode file. But I will have to check now. Anyway, I thought that would be a pretty good example of what MillenniumOS is designed to achieve. What I'd like to add to it is more probing operations, say for example probing a rectangular workpiece, so say for example putting being able to probe the outside corner of a workpiece. I think this is usually referred to as vice corner zeroing, so it finds a position on this surface and on this surface and also on the top surface at once. So we can have some macros that do all 3 axes at once, not just 1 or 2. And particularly with square or rectangular items like this, we can also calculate the angle of these surfaces and make sure that the part is actually aligned properly within the machine's axes. So we can calculate the angle of these faces and whether this is even a square corner. So I'd like to look at that. And as mentioned before, the other thing, also probing with a tool radius offset on the tool setter, so we can check where the lowest point of the tool offset is. But yeah, I thought that would be a good example of what I've been working on, and hopefully it was interesting. Cool.